likelihood is 30%, so on and so forth. And then we sample separately from each interval. So basically, we just pick up some samples from the, let's say, universe of the events that are likelihood to happen at 10% only. And then we move on to the another universe, which can be like likelihood to happen 20%. All the samples within that universe, or let's assume a basket, within that basket, the probability for all is 20%. All we just sample is the random events or the random scores, let's say. This is also called the stratified sampling without replacement. And this typically leads to faster convergence than Monte Carlo procedures using standard random sampling. In this example you are seeing on the screen is illustrating the sampling methods. In one-dimensional standard sampling, we just do 3 steps. The first one is generate a random number from a uniform distribution between 0 and 1, which is like the cumulative distribution function, and the distribution levels between 0 and 1. You see, this is the least likelihood and this is the most likelihood. And then use the inverse cumulative distribution function of the target distribution, which means the percentile function, to calculate the corresponding output, and then repeat. Illustrated to the right with the normal distribution. So if you see this one, this is the normal distribution that peaks out here. This is half of the curve, and the curve continues this side towards the right. But as we already reached the peak, which will happen, which means that probability is 1, which means 100%. So this one is enough to represent and fit the normal curve between least likelihood and the most likelihood values. This is the base, and then we are repeating it many times for Monte Carlo simulations. The number you are repeating it is up to you, but usually as the computers are really fast, we take millions of runs within a matter of minutes. For example, this one is the first randomly selected point. It is somewhere between like 0.3. And then we just calculate the corresponding output over the graph. So 0.3 is falling here somewhere, minus 0.1. Again, we are repeating it. We just randomly select another one, and we are just noting it, the value of x. Now what we have done, we have split the intervals for, let's say, 10% each. 10%, 10%, 10% until it is 100%. We split the intervals into 10 equiprobable intervals, and then we propagate it via the inverse of cumulative distribution function to the output distribution. We took n divided by 10 standard samples from each interval of the output distribution. Let's show what it means. So we have taken 10 samples from each. As you see, their probabilities are depicted on the y-axis, and their distribution quantile is depicted on the y-axis. Spacing of red points is regular. More space between blue points near the tails of the distribution. As you see, the distance here, or let's assume distance here is greater, but they are closer here. Distance here is smaller than the distance here. So which means the distance gets closer when it comes to the tails, although the distance here are equal to one another. So each of them 10%, which means that, we are dealing with Latin hypercube sampling. Otherwise, we wouldn't be fitting a normal distribution curve here, and all will be equal to one another. But as a note, you see this method assumes we know how to calculate the inverse cumulative distribution function. We will come to that, so no worries about it. Just other sampling techniques. Another random sampling technique you may see in the literature is use of low discrepancy sequence to implement quasi-Monte Carlo sampling. I'm not going to deep dive into that, but low discrepancy means quasi-random. So we are still using random numbers, but this time those random numbers have predefined limits. I'm skipping this. This is just for your general understanding, increasing your knowledge about it. But if I deep dive into this, I clearly see that it will make you more confused. And it is not required at this stage. So I am just skipping these. And there is an example of St. Petersburg game, which is to show us the limits of Monte Carlo simulation. Therefore, it might be worth visiting. So in this game, you flip a coin repeatedly until a tail first appears. So which means that it is quasi. We have defined a condition now. We are not looking after randomness. Of course, we are making it with randomness, but we clearly start a new condition when the head appears for the first time. You win whatever is in the pot for the first time you throw tails, and the game ends. For example, the first step is T. You got the T, tail on the first toss, and you win €1. If you toss heads and tails, which means that you got tail on the second toss, you win €2. If the thing is it's heads and tails, you win €4. And similarly, on the fourth toss, you have obtained this time first three were heads and the fourth one was tail, and this time you win €8. As a reminder, you can just check the associated slides on economic viewpoint on risk transfer, with expected value of this game is infinite. Then let's estimate the expected value using a Monte Carlo simulation. It was again described in Python, and the conditions were exactly described as, the pot starts at €1 and doubles every time head appears. So doubles every time the head appears, and the probability is 0.5 because we are still dealing with randomness, but we are defining the payoff. Every time the head appears, it pays double. This game illustrates a situation where very unlikely events have an extremely high impact on the mean outcome. Monte Carlo simulation will not allow us to obtain a good estimation on the true, or let's say expected value. Because of the uh, graph we have mentioned, the distance between towards the ends of the graph distribution is not equal. Those are closer to each other. So we've got many results here populated, but we got less results here. Therefore, we will not get a healthy, a secured, healthy, reasonable solution through Monte Carlo in this condition, because there is a condition described. It is not random anymore. It says every time that happens, then we should make the double payment. So it breaks down the, how shall I say it cancels out, blacks out the full randomness, and it turns out to happen the quasi-random now. I know for some of you it might become very confusing, but as we have more than half an hour, please ask your questions. As I mentioned, I clearly see that some of you really needs help with playing with numbers. Therefore, I just skipped those few examples because they require some higher levels of skills to go through. And if I have gone through them, some of you for surely got easily lost. Therefore, I highly recommend, as we are starting from the very basics in today's tutorial, please make all the efforts to join it, especially if you are suffering with calculations. Just say which point you were confused. Did you get my example with square and the circle and the randomness in it? Did you get it? Did you get the notion of it? If the answer is yes, then which means that there is nothing to confuse. You got it right. If you got it, if you digested it, how we calculated it. For example, I could do it rather than 10,000 this time. If I have done it, let's say with only 100 rice grains, we will probably end up with something like 3 for pi value. As we increased it to 10,000, it became 3.14. So it gets closer. If we increase it to 1 million, it will get even closer to the real value of pi. All the other examples were addressing the same issue, but for different situations. Therefore, I didn't go through them. This was the simplest answer, the simplest case for you possibly to digest, I have seen Hira's question, but what do you mean by 3? Turn your microphone on and ask it directly, please, because it's not clear in your condition. What I would try to say, if you are trying to mention that I reduced the number and the pi became 3-ish, if you are asking that, it is just for, it is more likely that we are not going to have an accurate value closer to 3.14 because we decreased the number from original test was 10,000. This time I am doing it with only 100. It will be probably roughly around something 3, because to obtain better calculation, let's assume we are just doing it with 10. So in this case, it would be 3, probably. Because, we don't have broken rices to make it 3.14, right? It will be either 3 or either 4. Both are wrong, which means that we shouldn't be doing that experiment with 10 grains only to define the size or magnitude of pi. Because we know that pi is greater than 3 and smaller than 4, isn't it? So which means that we are going to repeat the example with 100 grains. It will make us getting closer. If we increase the number to, let's say, 1,000, 10,000, 1 million, 10 billion, quadrillion, whatever it is, the more you increase the number, the more you will get closer to the real value. That is the all take home of this today's lecture. Don't get stuck with the numbers. Just focus on digesting the importance of randomness to do the experimentation. And yes, because we don't have it's good that you digested it, Hira, because if we just repeat it with 10 grains, as we don't have the broken grains there, it would be either 3 or 4, but it is close from being accurate, isn't it? So therefore, as the more we increase the number and we know the ratio to compare it, the closer we get to the actual value.
Good morning, Dr. Zafer.
Good morning. Go ahead.
Yeah, question is that uh, the course is like going for big data, I would say, because NumPy and all these libraries most of the time used in big data or artificial intelligence. So I'm asking that what is the ratio of that thing? Like, are we going deep into it or just
No, we
have a
are in our examples, as it is a fundamental course and it is not a data science course, we are not deep diving it. We are just going to use Excel and we will be just dealing with, in our case, it will be like a data set around like few hundreds.
and one more question? That are the data sets would you would be providing, or we need to just
Yes,
search
we
by
will be
ourselves?
providing the data sets.
Okay, great.
But as I said, in each time, it will be generating a random order for the data set. So
Okay,
you will be clearly able to demonstrate it, because we already have developed an Excel sheet for that. Every time by applying each step of trial, you will be able to see how the distribution changes. The graph changes each time we run the new simulation. And we are going to see how it gets closer to the actual normal distribution, how it is getting more fit to the distribution line. In the first run, it is something completely unlikely to be fitting to distribution. But let's say if we run it for 100 times, we can even visually observe the graph is getting a closer shape to actual curve fitting. And imagine you run it like 10 billion times, it will fit almost perfectly to a bell-shaped distribution.
and one more question. Don't you think that by processing like
I lost you. Your question was not clear. Can you repeat it again?
the question is that while processing the huge data sets on Excel, don't you think that Excel would be stuck by processing that huge quantity?
Our data set is just a small one, few hundreds. It's nothing for Excel. Excel can handle up to few millions of data
Okay, great.
without
Thank
any
you.
hassle. But imagine you are like doing some, just giving an example from your data sets, geographical conditions. Can you imagine like one square 1 square meter of geospatially labeled data for the whole world surface? What would be the
And
size of the data set to handle it?
small, very
It's
small.
a, yeah, the size would be very small, and the data points will be
Yeah,
billions of it, isn't it?
yeah, definitely, definitely.
If not even more.
Mm.
So in this case, Excel would definitely fail. Therefore, we would require tools like NumPy or things like that.
Yeah, definitely. Thank you, Dr. Zafer.
Yeah, you're welcome.
Hello, doctor.
Hello.
Yes, this is Anu speaking, sir.
Can,
It's not
can,
really a question on the
can you
classes.
speak a bit louder, please? Or
Alright.
just closer to the microphone?
Can you hear me, sir?
Yes, much better. Thank you.
All right, sir. It's not a question on what we are being taught. I just want to ask concerning the course. Is there a possibility that we'll be going to school, like having a physical class on this particular course? Maybe like lecture or tutorials?
The only thing is, I think, because it is government's decision to do a hybrid approach, and the university has only selected projects in practice course for physical delivery. And I don't know what is the case for Paisley campus, but I know that Dr. Hazar is running uh, physical classes on on London campus for PIP course. That is the only one for this trimester, as the university has announced us. For my course, Project Management Fundamentals, the only thing was, normally we shouldn't be doing that, but the university asked us voluntarily if we could do that. So I came to campus for a drop-in session, and some of your colleagues were there. We already did an introduction to ourselves, and we did some Q&A sessions for further clarifications based on either the topics or be it anything general apart from PMF course. And it was on week 6, and it was the only physical contact for PMF on campus. And for this course, the risk course, I think you need to contact Dr. Evie or Dr. Hazar as well. But I don't foresee any physical tutorial or class on campus for risk course.
All right, so I just feel it will help us a great deal if you can have a physical class rather than, most of these calculations, we are a bit, confused about it. And if it was physical, we'll be able to tackle it better.
Yeah, I totally agree with that, but it is the government's decision to do it hybrid way, and therefore we can only, the university has decided, rather than each class, each topic going like once or twice, they decided one full topic to be handled on campus, and it was selected as PIP this term.
All right, thank you, sir.
But we will try our best to take it from the very starting level to do the calculations, and we will take it to the higher levels of even enable you to running a Monte Carlo. All you need to do is just to follow the tutorials. Please make all the effort, you catch the tutorials. Okay.
All right, sir. Thank you, sir.
And for this week's tutorials, they are already available on Aula on week 9.
All right, sir. Thank you very much, Dr.
You're welcome. And to be honest, as I am just a guest lecturer of few weeks of this course, I see I'm giving this answer towards the question raised in the chat. One of your colleagues, Stefan, is mentioning our second group assignment. To be honest, the explanation should already be in Aula. If not, it will be there for sure. Either by Dr. Evie or Dr. Hazar, they will put it there for you. But if I am not wrong, as far as I know, your second assignment should be about Monte Carlo simulation, isn't it? And if it is about Monte Carlo, then it shouldn't be, earlier than 2-3 weeks, because, the next 2-3 weeks will be the delivery of content based on the Monte Carlo. So without completing them first, it would be not possible for you to handle it if the topic is about for the assignments and submissions, you need to stick to Aula announcements from your main lecturers, the main responsible lecturers of this course, as I said, because I am not in charge of the overall course, and I am just delivering few numerical bits of this course. So just ask your tutors about it. Any other questions or comments or any issues that you want me to clarify? It could be related to the lecture this morning or something in general, because we still have time till 12 o'clock, and then we are going to have a break. And as I told, I am going to meet London students for the tutorial slot, and Dr. Rehab is going to meet Paisley students. And the questions are available on Aula in risk management related page on week 9. There is a subheading named as tutorial under week 9, and just all you need to is just to visit there, and there you can find the tutorial questions for today. We are going to only cover 1 and 2. The third one is for your own pace. You do it on your own time. And then there is a supportive Excel presentation and questionnaire and something related to Excel for you to work on your spare time. It is just for your own learning, to make preparations for the next weeks. The attendance is automatically taken through Teams. There is a software for that because you now joined, so it will take recording for that. We are not taking manual attendance. So you are in now and it is recorded already, Shehrish. So don't worry about it. Any other issues, guys? Do you guys have any questions?
No, sir.
I see one question from Hafiz Muhammad Jawad, and he says, what about the latecomers, the late enrollment? You know, all content is there. Attendance should be all right. It should be taken right after the week you have been enrolled. It will be taken into consideration, of course, when you enrolled. The only attendance will be based on for the remaining weeks. That's it. So for example, if it is like minimum 10 weeks for 12 and you enrolled on the 6th week, so it will be like 5 out of 6 for you rather than 10 out of 12. It will be just a proportioned value for you. Start counting on the day you enrolled. Any other issues, guys? It says review and reflection on week 13. I think it should be better discussed with the main lecturer. I think they are just going to tackle the progress, and I will say what I do in my PMF course. I usually cover some important points again. I just revisit the contents from past weeks and cover them again. That's what I do. But I don't know what the responsible lecturer for PRM will do on week 13. It will be probably similar approach. It might be either a Q&A session. You ask them the points that you are still confused, or they might decide to go and repeat few issues they feel that is important and needs to be revisited, or they might use that time as buffer zone if they had any topics remain still uncovered. They might use that week to finish and cover all the topics. Any other issues, guys?
Yes, Dr. Zafer, is there any hands-on practice in campus regarding Monte Carlo simulation?
No, nothing on campus.
Any supportive links?
We will share you the Excel sheets and we will go through live and we will do hands-on practice on Monte Carlo.
Okay, great.
And I will chase it with other colleagues if they are, they feel it is worth like creating some extra sessions or maybe sharing few supportive videos. We will let you know. They will post it on Aula. And we also have recordings from previous years, but the recordings are not very clear. Therefore, I decided to go live today because there was a lot of background noise on the recording from last year. Therefore, I preferred going live today. But as I told, that is totally understandable that some of you might have struggles with the numbers, playing around with numbers, doing a bit calculations. So we will start with the basics today. Standard deviation and variance. Those will be the input parameters that we're going to tackle in Monte Carlo simulation in the coming weeks. Okay. So any questions? If no questions, the lecture is over, and in 1 hour's time, we will be seeing you I'll be seeing the London students, and Paisley ones will be with the Dr. Anna. As I said, Junaid has mentioned a good topic, but the notion of this hands-on stuff is for today's lecture was purely on the importance of randomness and how we use it. If it was not Python terminology, Junaid, and if it was something else, a software, trust me, it would be similarly same confusing for some of the students. So it is always a hassle. So therefore, I don't know whether the school is going to accept that if we can do it on campus. But if we do it on campus, we should make arrangements for both campuses. So I can just do it for London campus, and somebody else has to take it for Paisley campus. When it comes to hands-on issues with the Excel, so you will be, much more clear about it. Don't worry about it. It's pretty straightforward, and the Excel sheets we are going to provide are very clear. Any other issues? And let me do another reminder for Junaid. I recall that you have taken your note for tomorrow regarding PMF updates on Aula. My concern is still valid. I have dropped another email to Aula team as a reminder. But if you can't see PMF content on Aula by, let's say, tomorrow 10 a.m., just drop me an email and let me know, okay? Because I clearly see them on my screen, but it is not depicting on student side. So by tomorrow, let's say morning 9, 10 a.m., if you just please take your time and visit PMF page on Aula and just drop me an email whether you see the content or not. Okay.
Hello, doctor.
Thank you, Junaid. Hi there.
Hi, this is Anu again. For lesson 4 PMF now, I don't know if you have video recordings for it because I can only find the slides on my email.
As I said, everything is populated, but it is not just depicting on your screen. That is why
not
I
on the Howler now, sir. Not on the Howler. The email. You usually send emails to us.
Whatever it is in the email is there. If I have provided the link, it should be there.
I can only find the slides. I don't know.
Then probably it was just a live delivery and the slides were there.
Okay. All right, sir.
But everything for sure, if there is a recording for that, it will appear on Aula. I dropped them a follow-up email, but it's worth making sure about it. It's not depicting it at the moment. On campus is running on Tuesdays for PIP course for London. I don't know who is running the class on Paisley. Yes, Muhammad, that's what I'm mentioning. Junaid has already taken his notes, and by tomorrow, if nothing appears on your screens, he will drop me an email as an update, so I can just deep dive into the issue because they already promised me that it will be available by today. And as they said by today, I'm expecting it to happen until the end of today. So I'm not going to chase them right now, but I'm going to chase it. If it doesn't appear by tomorrow, I'm going to have a deep conversation with them once again. And I see if you didn't submit the first assignment, you had to apply for ECS. Yes, ECS is something that you need to apply if you missed a submission, if you missed attending a quiz, or if you are not happy with your submission. But there are certain deadlines for that, and you need to check it with your related courses lecturer. I see one question from Numan Mushtaq. He asks for material for individual assignment, but individual assignment for what? PRM? To be honest, I don't know. I need to check. It should be there. Or just simply chase it with whoever the governing lecturer of this course. I think it is either Dr. Evie or either Dr. Hazar for this lecture series of PRM. Just chase it with them. Okay, Numan. All right, guys. I can take a couple of more questions, but the time is about to run. And just let me remind you once again, especially for the guys who are struggling with calculations, please join the tutorials, okay? And if no questions, I want to thank you all for joining me this morning, and I can say that the lecture is over. Thank you.
Thank you, sir.